So today, this is going to be something a little different. So this is what you're going to need to do. You're going to need to pay attention. And if, anything doesn't make sense, please ask. But this is going to be a little different. So I'm sure you're looking at this first problem and you're saying, oh, that's a piece of cake. I can do that. All right, so let's go through and what do you do here? You add 3 very first. And so then I end up getting 4m to equal 11. Then what do you do? Divide by 4, and so you get m to equal 11 fourths. Now what we're doing today is no different than that. It's no different than that, but this is what we're going to be looking at today. Instead of it being a 3, it's now a 3n. So now what we need to do here is we need to do the exact same steps. So the first step here was to add 3, right? So what's the first step here going to be to do?
Add 3n.
Add 3n. So I end up getting 4m to equal 8 plus 3n. No, that's not 11m. Okay, you can't combine them. They're not like terms. You leave it like that. Then what did we do over here? Divided by 4. So I'm going to divide this by 4. So all I'm left with on the left side is m. On the right side I have 8 plus 3n divided by 4. And that's all you can do.
Piece of cake.
So is that no solution?
No, that's your answer. That is your answer. You don't do anything more. You can't do anything more.
But aren't they the full like terms?
You could, but then you're going to have to divide the 3 by 4, so you're going to have a fraction anyway. So you might as well just leave it as it is. So let's go ahead and look at this one. 3n plus 6p equals 15. So this is real similar to the following problem. 3n plus 6 equals 15. So I want you to look at the purple problem and tell me what you would do first. You subtract 6. So I'm going to do this over here, except for instead of subtracting 6, I'm going to subtract 6p. So on the left side, I'm going to end up getting 3n. What do I get on the right side?
15 plus minus
15 minus 6p. Now what do you do? Divide by 3. So my n ends up being 15 minus 6p all divided by 3. Now if you notice, what do you notice about 15, 6, and 3? They're all divisible by what number? 3. So since they are all divisible by 3, I'm going to take 15 divided by 3, and what do you get?
5.
I'm going to take 6 divided by 3, what do you get?
2.
3 divided by 3 is
1.
1. So really, I don't have a fraction anymore, right? And so I end up getting n to equal 5 minus 2p. Now you could have put it over 1, but then you would have just reduced it down. And that's it. So questions? All right, now this one. Ooh, this is a good one. What do you think you do on this one? Okay, let's think about that. I gotta get rid of that 5, right?
Yes.
So what I can do is multiply this side by 5 and multiply this side by 5. On the left, those are gone. So I'm left with k minus 2. What do I have on the right? 55j.
Why were you able to multiply those?
You can multiply those. And that's like saying if I had 2n and I took it times 3, you would say that's 6n, right? Okay, multiplication, you don't need to have like terms in order for you to multiply them. And so that's why you can combine those as opposed to the ones when we add. So now what do you do? Add 2. Very good. So I end up getting k to equal 55j plus 2. And there you go. Okay, about time for you to give it a shot.
With our expressions?
Oh.
Oh, are you supposed to have expressions?
I'm gonna give you about 30 seconds right now. I want you to think about what would you do to solve that?
Ask you.
Well, that'd be an option. I'm gonna give you, like I said, about 30 seconds right now to try and figure out what do you do there.
I didn't see the
28 equals t times r plus 4. What do we do? Okay. Interesting. You what? Okay, so I want you to think about what happens if I would have given you this as your equation.
You do the thingamabobber by.
What would you do?
Divide by 4.
You divide by 4, right? The problem I have over there is exactly the same. I have 28 equals t, here's your t, and then this is similar to the 4. So in order to solve, what did we do here? We divided by the 4. So what are we going to divide by over there?
4r.
I'm going to divide over there by r plus 4. I'm going to divide over here by r plus 4. Now, if you distribute, that's all fine and good, but you're going to end up having to go back to this step anyway. So that's why we need to go ahead and just leave it as it is. So on the left side, I have 28 divided by r plus 4. On the right side, I have an r plus 4. You can cancel them. What does that leave you with?
T.
T. See how slick that worked? All right. Solve this one. Now, if I said for A, that would be pretty easy. That would be just like the one we looked at, right? Okay. This one isn't for A. What is this one for? What do you think you're going to do first here?
You divide by 1a. Because it says multiplication, doesn't it? The a.
That would work. I would probably distribute first, okay? On here, I would probably accept 2 answers. You could go ahead and divide by A if you wanted to. I think it might be a little easier to understand this way. So now we need to get the n, and your way might work too. What do you do first? Add 8a. So on the left side, what am I left with? an equals
23 plus 8a.
What do you do now?
Divide by a.
Divide by a. So you get n to equal 23 plus 8a all over a. So that will work. Okay. Now, Lane said, well, could I multiply by 1 over a? And the answer is, yeah, you can. If I would do that and multiply by 1 over a, on the left side, what happens to your a's? They cancel, and I've got n minus 8. On the right side, I have 23 on top. What do I have on the bottom?
A.
A. So then how would you solve that for n?
Add 8.
Add 8. So what would end up happening is you would get n to equal 23 over a plus 8. And that is actually equivalent to what's in orange. So you could have one or the other. Doesn't matter. It's whatever way makes sense to you. Okay? Oh. What's the problem here?
There's variables on both sides. And
Yeah.
there's 2 on it.
There's 2 what?
Same.
Different ones.
Two of the same
What are we solving for?
X.
X.
I didn't even see that.
So what do you notice about the x?
They're both in the beginning.
You got one here. You also have one. Oh, I didn't want that to be 3, but anyway, we'll go ahead and, I'll see if I can just go ahead and get that. Nope, I guess it's gonna go ahead and do my 3. So anyway, if I notice on that one, there, okay? The z, I guess it changed the z too. So if I notice on that one, I need to solve for x. But how do I do that if I've got 2 of them? Combine them. So to combine them, what do I know I need to do?
Add 3x.
I need to have them on the same side. So our first goal, get all the x's onto one side. Everything else needs to be away. So what I'm going to go ahead and do is I'm going to go ahead and move the xz over here to the left. So what I end up having now is 3x minus 2y minus xz equals 5. Now remember what I said. All the x's on one side, everything else on the other. So what do I need to do? I need to add 2 what? 2y. So on the left side, I end up getting 3x minus xz equals what?
5 plus 2y.
5 plus 2y. Now you notice that I have all the x's on one side and I each have an x. I'm going to show you something known as factoring, which we're going to probably spend close to a whole chapter on coming up. Okay? Since each of these has an x, I'm going to take an x out. And so when I take an x from 3x, that leaves me with 3. If I take an x from xz, that leaves me with z. So basically what I've done is I've done the distributive property in reverse. So if I look at this and distribute my x, I would have 3x minus xz. So basically I took the x away from the 3, took the x away from the z. Kind of split up the couples. And then that's going to equal 5 plus 2y. What do you do now? Remember from the time before. Remember that one I asked you and I said, what do you do here? Divide by the quantity 3 minus z. Divide by the quantity 3 minus z. So on the left side I end up getting x. On the right side I end up getting 5 plus 2y over 3 minus z. Now obviously I can see that we're going to need to look at another one of those. Okay, so we're going to go ahead and look through another one of those right now. So 6x minus 18 equals xy plus k. I want you to go ahead and get started. I'm going to give you about 30 seconds to get started. What should you do first? What should you do next?
Try to get your variables on one side.
So very first step. Okay. So I already see some of you have written this step down, so I'm just going to go ahead and write it up here on the board. Okay, so up here on the board, you're going to notice the very first step. And so you have 6x minus 18y minus xy equals k. So I moved that xy over. What should you do next? Yeah, add 18, because I want to make sure that I have the x's on the left, everything else on the right. So I end up having 6x minus xy equals k plus 18. Now remember, this is the step where I'm like, well, how do I solve for x? I've got one in each.
Reverse distribution.
Yep, so that's where I'm going to go ahead and take the x out. So when I take the x away from 6x,
6 minus
6 minus y. And that's going to equal k plus 18. My final step will be to go ahead and divide by the 6 minus y. And so I end up having, when the 6 minus y's cancel, x equals k plus 18 over 6 minus y. Questions on that? All right, so now I need you to go to number 24 in your book. Because we're going to actually do one problem on your homework right now. So go to number 24 in your book. It is on page 129. So let's go to the instructions. The instructions say, select an appropriate unit from the choices below and convert the rate to the unit. So basically, I'm starting with 36 feet per second. I need to determine, should I convert feet per second to miles per hour, millimeters per second, or kilometers per second? So you need to think, what is feet most closely related to? Miles. Okay, so I'm going to convert this to miles per hour. And so I don't know if you remember doing anything like this. I've got 36 feet per second. Does anybody remember the conversion between feet to miles?
When you flip flop
5,280 feet equals 1 mile.
And it'd be 1 mile.
Okay, so now in order to convert that, what I'm going to do is I need to convert feet to miles. So when I think about multiplying, if I want to get rid of feet, I need to put feet in the denominator. I need to put miles in the numerator. Conversion between the two, I know that 5,280 feet equal 1 mile. So now the beauty of this problem is that now the feet cancel. So when you think about it, I've really got miles now over seconds. And so now what I need to do is convert the seconds to what? Hours. So seconds to hours, if I want to get rid of seconds, I'm going to put them on here on the top. I'm not going to go seconds directly to hours. I'm going to go seconds to minutes. And I know what's the conversion between the two. 60 seconds equals 1 minute. So now when I cancel out my seconds, what's my label really now? Miles per minute. Well, I don't want minute, I want hours. So I'm going to put the minutes on the top here, hours on the bottom. What's the conversion?
60
Minutes equals 1 hour. So now cancel, cancel. So let's look. On the top I have miles. On the bottom you have hours. We're good to go. All we need to do is calculate this. So I need to take 36 times 60 times 60, and that'll be my miles. On the top, on the bottom, I've only got 5,280, and then hour.
times 1.
Okay, all of those are times 1, but that's what I need to calculate. So I need you on your calculator then to go ahead. 36 times 60 divided by 5,280. What's it come out to be? 24 what?
24 miles an hour.
So 24.55?
No, 24.
To round it, yeah.
Yeah, well, yeah.
24, she said .5454, which is 24.55. So there you go. Now, real quick, let's look at 25. 25 says a snail moving at 3.6 meters per hour. 3.6 meters per hour. So let's go ahead and look at 25. Okay, a snail moving at 3.6. So this is number 25, right?
Yes.
25. So the snail is moving at, what was it?
Miles.
3.6.
Meters per hour.
3.6 meters per hour. And so what would be a good thing to convert that to?
Kilometers per second.
Kilometers per second, yep. So now, kilometers per second, for those of you that didn't know, 1,000 meters is equivalent to 1 kilometer. Also, I know that 1 meter equals 1,000 millimeters.
Wouldn't you want to do millimeters? Because you'll get so many decimal points if you do kilometers.
The snail is moving at 3.6 meters per hour. If I were thinking about a snail moving that, I would probably go millimeters per second. Okay, because the snail isn't moving very far. So we want to convert this to millimeters per second. So now, how I'm going to start? I'm going to start with 3.6 meters on the top, hours on the bottom. So I need to convert meters to what? Millimeters. So to change, I'm going to put the meters on the bottom, I'm going to put the millimeters on top. Conversion is that 1,000 millimeters is equivalent to 1 meter. What ends up happening? Your meters cancel. So what's my label right now?
6,000.
Millimeters.
Millimeters per
Hour.
hour. So now what I need to do is convert hours then to,
Seconds.
I would go hours to minutes first.
Okay.
I know in 1 hour there's 60 minutes. And so what ends up happening is your hours cancel. And so my label currently would be millimeters per minute. And so now I'm going to go minutes to seconds. And I know that 1 minute has 60 seconds. So now my label is millimeters per second. On the top I've got 3.6 on times 1,000. We got the green right there. And then on the bottom I've got 60 times 60. And my label here is millimeters per second. What does that come out to be?
He's just been hanging in the office for a little bit.
That's
0.1.
I got one.
so 3,600 divided by 3,600, so 1 millimeter per second. Okay. So now, I've given you help on 2 of those, so we're going to go ahead and go back to your assignment. This is your assignment. 8 through 15 all, 16 through 22 the evens, and 24 through 27 all. And we've already done 2 of those.
So do we have to just rewrite those out?
Yes. Yes, you do need to rewrite those out on your homework.